Another way of looking at the 6 trigonometric ratios on this new thing called the unit circle is to know that the point on this red ray where the ray hits the unit circle is the ordered pair x comma y. So if I create a right triangle with the x-axis, then we would call this side of the triangle x because it's some x number of units on the x-axis. This vertical line we would call y because it's some y units up, and then you get to the point x comma y. The hypotenuse of that right triangle is the radius of the circle. And then theta, our reference angle, is the number of degrees between the x-axis and the hypotenuse, or in this case, the terminal ray, which is the one in red. So the 6 trig functions in this case become the sine of theta is y over r, so the cosecant is r over y. The cosine of theta is x over r, so the secant is r over x. And the tangent is y over x, so the cotangent must be x over y. Because this is a circle whose radius is 1 and it's centered at the origin, the equation of this circle would be x squared plus y squared equals r squared. Remember, this equation of the circle was x minus h squared plus y minus k squared equals r squared. But in this case, since the center is at 0, 0, h and k are 0 and 0. So if I know a point where a terminal ray hits the unit circle, x comma y, then I can find r by taking the square root of x squared plus y squared. Example 4, find the values of the 6 trigonometric functions for theta in standard position if a point with the coordinates -15, 20 lies on its terminal side. So the first thing you're going to do is you're going to determine what quadrant -15, 20 would be in. Well, if you were to plot it, -15, 20 would be in quadrant 2. So I'm going to draw a terminal ray somewhere in quadrant 2. We're going to create a right triangle that we're going to solve in a minute, but you have to know how to make the right triangle. The ray always drops a perpendicular to the x-axis. Let me phrase that another way. The right triangle that we're going to create, one of the sides of the right triangle must be on the x-axis. So if you think about how you go about the process of plotting that point, you would go -15 in the x direction, you would go 20 up. Oh look, I know 2 of the 3 sides of the right triangle. I can use the Pythagorean Theorem to find the third side. Hint about the third side, it will always be positive. So if you use x squared plus r squared, x squared plus y squared equals r squared, which is just the Pythagorean Theorem, we're going to find out that r is 25. So now that I know the hypotenuse, the angle theta will always be this angle closest to the origin. So now we can go find the 6 trig functions. Now, do you actually have to go use those new definitions? The answer is no, because you really can just use SOHCAHTOA to find sine, cosine, and tangent. But for the sake of argument for this problem, I'm going to go use those new definitions. So the sine of theta is y over r, because that's opposite over hypotenuse. You get 20 over 25, which reduces to 4 over 5, which means the cosecant must be 5 over 4. The definition of cosine is x over r because that's adjacent over hypotenuse. It's -15 over 25, which reduces to -3/5. So the secant must be -5/3. And the tangent is going to be y over x because that's opposite over adjacent. That's 20 over negative 15, which reduces to negative 4/3. So the cotangent must be negative 3/4. Let's take a moment to look at the signs of your x and y coordinates in your ordered pairs on the coordinate plane. In quadrant 1, both coordinates will always be positive. But in quadrant 2, because you're in the negative x direction, x will be negative, y will be positive. In quadrant 3, both x and y will be negative. And in quadrant 4, you're in the positive x direction, but the negative y direction. Now let's go apply that to these new definitions. We said the sine of theta was y over r. So I want you to note, so the radius r will always be positive. But let's look at the y coordinates in each of these quadrants. In quadrant 1, y is positive, so the sign should be positive. In quadrant 2, y is positive, so the sign should be positive. But notice in quadrant 3 that y is negative. Therefore, sign would be negative in quadrant 3, as well as quadrant 4. So the sign is positive only in quadrants 1 and 2, but negative in 3 and 4. Now let's look at cosine, which is x over r. Because it's x over r, cosine is going to be negative when the x coordinate's negative, and positive when the x coordinate's positive. I want you to notice that cosine will be positive in quadrants 1 and 4, but not in 2 and 3. Tangent is y over x. The only time that y divided by x will be positive is if y and x are both positive, or if they're both negative. Remember, a negative divided by a negative is a positive. So it turns out tangent is positive in quadrant 1 and quadrant 3. We have a method for helping us remember what quadrants, sines, cosines, and tangents will be positive in. If you're worried about the other 3 trig ratios, remember, if you do the reciprocal of a positive number, it stays positive, and if you do the reciprocal of a negative number, it stays negative. So we use this little acronym. It's all students take calculus. And the way that it goes around the unit circle, or around the coordinate plane, I should say, is it starts in quadrant 1 and then it goes to 2, 3, and 4. I've also heard some teachers say all students take cake, but this is pre-calculus and I'd like to prepare you for calculus. What it stands for is all of the trig functions are positive in quadrant 1. But only sine was positive in quadrant 2. If you look back at this picture, sine was the only one we put in quadrant 2 for positive, and in quadrant 1 we wrote all 3 of them. Tangent is the only one positive in quadrant 3, and cosine is the only trig function positive in quadrant 4. Everything else would be negative. So the last problem we're going to work on here, example 5. Suppose theta is an angle in standard position whose terminal side lies in quadrant 4. If the secant of theta is the square root of 29 over 5, find the values of the remaining 5 trigonometric functions of theta. First of all, you should always draw a picture of what quadrant your triangle is going to be in. The hypotenuse of the triangle that we draw is your terminal ray, and one side of the triangle will be on the x-axis. So let's start with the fact that we know what the secant is. If I know what the secant of theta is, then I know what its reciprocal is. So the reciprocal of secant is cosine. So the reciprocal must be 5 over the square root of 29. The definition of cosine is adjacent over hypotenuse. All right, so they told me that I'm in quadrant 4. So I'm going to draw my terminal ray in quadrant 4. Then this side of the triangle is going to be on the x-axis. So here's my other side. This is going to be my right angle, and this is theta. Here's the side adjacent, and here's the hypotenuse. Now remember that the vertical and the horizontal side of the triangle represent an x and a y coordinate. Well, in quadrant 4, we just said that where is it? Here, that the y values are negative and the x values are positive. So in my triangle here, the length along the x-axis is positive 5. That means whatever answer I get when I find the missing side here, using the Pythagorean theorem, I need to make it negative. The answer I get is not going to be negative, though, but I'm going to have to make it negative. All right, so we're going to use the Pythagorean theorem to find the missing side. I'm going to use 5 squared plus y squared, because that's the y side. Remember, this is x, and this is r, is equal to r squared. 25 plus y squared is equal to, remember that squares and square roots are inverse operations, and they cancel each other. So y squared is going to be 4, and y is 2. Except we're not going to make this 2, we're going to make it negative 2. Now I know all 3 sides. I already knew my cosine. Remember, this is going to rationalize to 5 square root of 29 over 29. And I already knew secant. So the sine of theta, sorry, I'm forgetting theta here, is opposite over hypotenuse, which is going to rationalize to negative 2 square root of 29 over 29. The reciprocal of sine is cosecant. I'm going to use this to flip it, square root of 29 over negative 2. And then the tangent is opposite over, and then remember the adjacent was 5, so the cotangent is 5 over negative 2. And that was the remainder of section 5.3 on trigonometric functions on the unit circle.